So good morning, everyone. So once again, welcome to Physics by Physics. So in this session of C.T.P series, again we will take some question based on the electric field topic. So in last session also we have taken some example conceptual based questions based on the electric field. So let's see some more problem related with electric field. So we will take so we will solve from our QIP file. So topic is electrostatic and we are focusing on electric field, how to calculate electric field. We are taking example related with electric field concept. So we have taken some examples. Now see, let's see question number 12. Let's see question number 12. So question number 12 is a circular loop of radius r carries a uniform line charge density lambda. The electric field calculated at a distance z above the center of the loop is maximum. Now just see, they have asked you for what value of z electric field will be maximum. So you have to use maxima minima condition. So now see the question. You have a circular ring of radius r. Its uniform line charge density is lambda. And you know, as a function of distance, what will be the electric field at any point P? Let's say this is Z axis. So I'm taking this distance to be Z. So you know electric field at this point. This is the standard result. So you must remember it. So I'm writing magnitude only. Electric field direction will be in this direction. This is the direction of electric field. So that will be given by 1 by 4 pi epsilon naught lambda into 2 pi r. This lambda into 2 pi r is total charge over this ring. Because when lambda is charge per unit length. So if you multiply with its circumference, this will be the total charge. So sometimes they may give you total charge on the ring. So in this case, if you have to write, what will be Q ring? Total charge over the ring. So that is lambda into 2 pi r into z by r square plus z square power 3 by 2. So first thing is, you should remember the electric field due to ring. This is the standard result. You must remember. You don't have to derive it. Standard result you have to remember. Now you have to see at what value of z electric field is maximum. So let's take this condition. dE by dz should be 0. We will apply this condition. So take constant here. Constant value is what? I am taking lambda r by 2 epsilon naught is common. So if you differentiate, this is numerator z, denominator is r square plus z square power 3 by 2. So denominator differential of numerator minus numerator and then differential of denominator. So this is 3 by 2 under root r square plus z square and then 2z. This will be the value. And you have to take this value to be, this value you have to take 0. Take this value to be 0. So now what you will get, this 2 will cancel out and you will get r square plus z square power 3 by 2, and this will be 3z square. This is r square plus z square power 1 by 2. So if you divide it by 1 by 2, what you will get? So this value is r square plus z square, and this is 3z square. So now this will give you 2z square is r square, or you will get z is r by root 2. Z is equal to r by 2. And you will see at this z distance, second derivative will be negative. Second derivative will be negative for maxima. So because option is given, so z will be z is equal to r by root 2. So at this point, this will be maximum, and you can check that this you have to check. At z is equal to r by root 2. So here you have learned how to write the electric field due to ring, and then using maxima minima condition, you have to find at what value of some distance electric field will be maximum. So must remember this case. ठीक है? Is it clear? Now take another example. Let's see. Now you can easily solve this question. Let's see question number 16. Now I will solve question number 16. So question number 16 is an infinitely long, thin cylindrical shell has its axis coinciding with z axis. It carries a surface charge density sigma naught cos phi, where phi is the polar angle, sigma naught is constant. The magnitude of the electric field inside the cylinder. So one thing is, it is infinitely long cylindrical shell. It's a hollow cylinder. So let's see the symmetry here. And its radius is not given. So let's take its radius is r. I'm taking this radius to be r. Radius is not given, and sigma is given. Sigma is sigma naught cos phi. Sigma naught cos phi. And I'm taking this to be z axis. So assume this direction is x, this is y, and this is z. So it means if you consider any if you take this as a x axis, outside direction is x axis. So what will be polar angle? This will make with x angle is phi. You have a circle and this is x direction. So this angle is phi. So cos phi will vary. So from this point to this point, let's see, this is segment 1. I'm taking this to be segment 1. And in this, charge will be positive. Magnitude will vary, but its sign will be positive. So this is 0 to pi by 2. Then pi by 2 to pi, cos phi is negative. So you will get negative here. Again pi by 2 to 3 pi by 2 negative. Then it is plus. So this is segment 2. This is segment 3. And this is segment 4. Means you are moving over the cylinder. I'm talking about whole cylinder, because it's a surface charge. So over whole cylinder, this will vary. So this part will be, means on this part you will get positive. Then next part you have negative, negative, then you have positive value. Is it clear? So I have shown you on this, but this is throughout this cylinder. On the surface, charge will vary like this. And if you see only this cross section, if you show this only this cross section, then electric field is varying like this. Let's say if I am taking this is X and this is Y. So what will happen? This angle is phi. So this variation will be positive. This is negative. This is also negative. And this is positive. Okay? Here, this is phi will be, just see, phi is 0. Here, pi by 2. This is 3 pi by 2. And this is pi. This will be pi. Pi by 2 and pi. This point is pi. And this will be 3 pi by 2. And then again it will be 2 pi or 0. So it means now charge is varying, but it's a long cylinder. So what you have to consider, on the surface of this cylinder, I will consider a long, infinitely long wire. Let's consider an infinitely long wire over it. And this is the part of charge will be positive. Over this, it's a positive charge. Means this, there will be a positive charge here. Over this, there is a positive charge. I am just showing that because this is in 0 to pi by 2. And if you are taking this length of the cylinder is L, where L tends to infinity. And what will be this width? Take this width to be DL. I am taking this width to be DL only. This width is DL. This width is DL. So what will be total charge in this string, in this length of wire? And consider its charge per unit length is d lambda. It's an elemental wire. So we will calculate electric field due to this elemental wire, and then we will consider all the elemental wire on this surface of the cylinder. We will find the electric field due to each, and then you have to take vector sum. Clear? So what will be charge in this? dq. And this dq is given by d lambda into L, because its length is L. And in terms of sigma, if surface charge is sigma, what will be area of this wire? Lambda into dl. So this L will cancel out and d lambda will be sigma into dl. And sigma is given. This is sigma naught cos phi of dl. Is it clear? Now let's find the field due to this at this center. Means at this is on the surface. So if you write the field at any point, for example here, this will be the electric field. Take it as dE1. Take it as dE1. So magnitude of dE1 will be given by, what is the field due to infinite wire? Lambda by 2 pi epsilon 0 r. So I will take here, because this is elemental wire, d lambda by 2 pi epsilon 0 r. It's an infinite wire. So r distance away, direction will be just away from the wire, radial direction. If you see at this point, so I am showing like this, away from the wire because charge is positive. And d lambda is given by sigma naught cos phi. And what is dl? Just see, dl is, you can write dl as, if this is r, this is d phi. This will be dl. So dl is r d phi. dl is r d phi. dl is r d phi. Means I am showing this cross section. This is dl here. So at this point, electric field is dE1. And this is dl, and dl is given by rd phi. Clear? So this is sigma naught cos phi rd phi 2 pi epsilon 0 r. So this is for the segment 1 only. I have calculated the electric field. For phi varies from 0 to pi by 2. But there is a similar segment like this segment, this segment, this segment. In each case, symmetry is same. So we will find due to other segment also. So this is due to plus charge. This charge is positive. So electric field direction is away from it. But if you consider this segment, charge is negative. This charge is negative. So this field will be dE. Let's say this is segment 1. This is 2. This is 3. And this is 4. So this will give you dE3. This segment will be, means at this point you are considering. So one will give you D1, D3. They will be in the same direction. Similarly, if you consider any segment here, so field will be what? This will give you DE4, DE4. And again, due to this segment, DE2. So DE2 and DE2 and DE4, they are in the same direction. And magnitude of each segment will be same. Magnitude of each segment is same. DE3, and this will be magnitude of DE4. So you have considered all the segment. Now you have to find vector sum of all these. So if you resolve this in component form at this point, what you will get, there will be in this, let's resolve. So because this angle is phi, so this angle is also phi. So component of DE1 along this direction is, here you will get DE1 cos phi, and another will be DE3 cos phi. And there will be two component in this direction, DE1 sin phi and DE3 sin phi. Similarly, if you resolve DE2 and DE4, because of same symmetry, so I will take two component here. This will be DE2 cos phi, and this will be DE4 cos phi. And there will be two component in this direction. One is DE2 sin phi, and another is DE4 sin phi. So we have resolved component of DE1, DE3, DE2, DE4 along these two directions. So these component will cancel out. Just see, they are equal and opposite. So these two component will cancel out. And then resultant field will be, magnitude will be what? 4 DE1 cos phi. So now we have to calculate 4 DE1 cos phi. So just see, if you add, resultant DE is given by 4 DE1 cos phi. And what is DE1? D1 you can see, we have written, this is sigma naught cos phi by 2 pi epsilon. This R will cancel out. So sigma naught cos phi, this is sigma naught cos phi d phi by twice pi epsilon 0. This is twice pi epsilon 0 into cos phi. So this will give you sigma naught 2 sigma naught by pi epsilon naught cos square phi d phi. And because we have taken all the segments separately, so 0 to pi by 2, 0 to pi by 2. So when you integrate it, you have to integrate it with respect to phi. So this is 2 sigma by pi epsilon naught integral cos square phi d phi. Limit is 0 to pi by 2. Because we have taken all the 4 segments. For each segment, 0 to pi by 2. Numerical value will not change. And this value is 2 sigma by pi epsilon naught. And must remember this integral, whenever you have cos square phi, sin square phi, limit is 0 to alpha. So that will be alpha by 2. So this will be simply pi by 4. If it was pi, then it was pi by 2. Now you will get E is given by sigma by 2 epsilon naught. This is the magnitude of the electric field. Sigma naught, I am writing here sigma naught. Please write here sigma naught. Sigma naught by 2 epsilon naught. This is the electric field. So you can see the symmetry because it's a shell. Charge is varying over the surface. So you have to consider an infinite wire for each 4 segment. You have to find the electric field and then you have to integrate. So that's what we have done. So option B is correct. Sigma naught by 2 epsilon naught. Please write it down.
सर कंपोनेंट्स कैसे डिवाइड किए हैं सर, एक बार बता दीजिए.
Just see, we have asked the component. So at this point, we have seen there will be 2 components. This is segment 1. Here you have a segment 1, segment 2, segment 3, and segment 4. Yes or no? So this
Yes.
was DE1 and this was DE3. Magnitude is same? Yes or no?
Sir. Yes,
and
sir.
This angle was phi.
Yes.
So this is also phi. And when you have seen, there will be due to 4, DE4 and DE2, they will be in this direction. Yes or no?
Yes, sir.
So if you resolve this in component form, there will be 2 component of DE1, DE3. 2 component in this direction, cos phi, and 2 component in this direction, sin phi. Yes or no?
Sir, for DE1, 2 components in one direction, so one will be cos and one will be sin. Like for
Yes,
DE1.
yeah. No. This is cos phi. This symmetry is same. Now you have this angle is phi. You are calculating the magnitude, na? So because each segment have same symmetry. Now I am considering each segment has same symmetry. So that's why this angle will be also phi. Because same, I am considering this particular arc again and again. Let's say once you have taken this arc, so 0 to pi by 2. Again this arc 0 to pi by 2. Again this arc 0 to pi by 2. Again this arc 0 to pi by 2. Is it correct? So these are the cos phi component and these are the sin phi component. So that's why this sin phi component will cancel out. And then, and just see, we are integrating 0 to pi by 2 only because all the segment have same symmetry. So let's calculate for 1 Then 2, 3, 4, you have taken vector sum. Now integrate 0 to pi by 2. So that is how you can resolve in component form. Clear?
Yes. Yes, sir. Thank you.
Okay. Now take other examples. Let's see. Let's see this particular example. A small spherical ball, charge Q, mass M, is tied to a thin massless non-conducting string of length L. The end of the string is fixed to an infinitely extended thin non-conducting sheet. This is a non-conducting sheet with uniform charge density sigma. Under equilibrium, the string makes an angle 45 degree with the sheet as shown in figure. Find the sigma. G is the acceleration due to gravity. Epsilon naught is permittivity. So let's see. This is the string. Charge is Q. Mass is M. And this angle is 45 degree. So what will be electric field? Electric field E is given by what? You know, field due to infinite sheet, sigma by 2 epsilon naught, because it's a, you have a infinite sheet. So electric field will be sigma by 2 epsilon naught. Charge is positive. So this charge will experience force in this direction, and force is given by Q into E. It will experience force mg in downward direction. And there is a tension in this string. Let's say this tension in this string is T. This angle is 45 degree. So what will be the component here? This will be T cos 45, and this component will be T sine 45. So in equilibrium condition, you can just equate that T sine 45, T sine 45 degree. This will be T by root 2, and that is equal to mg. And then T cos 45 is equal to sigma q by 2 epsilon naught, q into E. And this is also T by root 2. So this will give you mg is sigma q by 2 epsilon naught. So what will be sigma? 2 epsilon naught mg by q. Is it clear? 2 epsilon naught mg by q. So option C is correct. This option is correct. Clear? ठीक है? Note it down. So let's see one last example I'm taking. Let's take this example. Question number 22. This has been asked in TIFR exam. So let's see how we will solve this question. You have consider an infinite plane with a uniform positive charge density sigma. Again, it's a uniform positive charge density infinite plane. A negative point charge minus q with mass m is held at a distance d. Is held at a distance d from the sheet and released it will then undergo oscillatory motion. What is the time period of this oscillation? But just see this point. You may assume that point charge can move freely through the charge plane without disturbing the charge density. Means it can cross it without disturbing the charge distribution or charge density. Under this assumption only you will be able to solve this question. So let's see what will happen. Now consider this charge is minus Q. This is the point O where the sheet is located. So what will happen? There is an electric field in this direction. What will be the electric field? Sigma by 2 epsilon naught is the electric field. This is the electric field. Let's in this direction, electric field is sigma by 2 epsilon naught. So this charge is negative. This is positive. So this will be attracted towards, it will experience force in this direction. Yes or no? This distance is d. So it will experience the acceleration. Just see, force is given by mass into acceleration, and that is Q into E. And this will be sigma Q by 2 epsilon naught. So what will be acceleration of the charge particle with which it is accelerating? This is sigma Q by 2 epsilon naught. This is the acceleration of the charge particle. So, and this negative charge will be accelerated towards the sheet. Now, it has to cover a distance d with acceleration a, and it is released at this point. So, initial speed is 0. So, what will be distance d covered? So, d is given by half at square. So, this will be given by d is equal to half sigma q by 2 epsilon naught m into t square. So what will be t here? T is given by under root 4 epsilon naught m into d by sigma q. This is the time taken. Let's say this point is A to O. From A to O, it will take this much time. Now what will happen? Once charge reach here, because it is in motion, so due to inertia, it will cross the plane, and now when it moves here, its force will be in opposite direction. Now it will experience force in opposite direction, and maximum it can go up to this point. Then again it will be attracted towards it, and it will cross it, it will move here. So you have to find total time. So that time will be same, means it will take t time here, then t time, return, and then to O. So total path will be A to O, then O to B, then again B to O, then again O to A. This time is T, this time is T, this time is T, so this time. So this will give you the total period. So this is 4T. And take 2 common here. So this will be given by 8 under root epsilon minus md by sigma q. So this is the total period. 8 times under root m epsilon naught d by sigma q. Is it clear? So these are the some examples or some problems that we have discussed, where you have seen what is the concept involved, which formula you will take, how you will solve it. Yes or no? So that completes the electric field part. You should solve other questions also. And if you have doubt, you can just message me or write down in comment section. I will take those examples also. Okay? So in next series, in I will take E.M.T. and we will talk about line integral and surface integral property of the electric field, and we will discuss the flux, Gauss law, and other properties. Is it clear? ठीक है? So then meet you in next lecture, next C.T.P series. Okay. Thank you, everyone. Thank you.